Number 88 here is kind of a wordy problem, so they're kind of giving you like a theoretical function here. They're not actually telling you what to deal with here, but they're giving you a decent amount of information about it. Let's see what's going on here. So f is a twice differentiable function, and our second derivative is going to be negative for all x. So that tells us right there that this curve definitely has to be concave downward. Now the graph of y equals s of x is the secant line passing through 2 points on this curve. Gotcha. We've got 3f of 3 generically named and 5f of 5, and then the graph of y equals t of x is the line tangent to the graph of x of f at x equals 4. And what they want us to do is establish the hierarchy here between f of 4.2, which is the actual value of the function, s of 4.2, which would be a secant line approximation to that value, and then t of 4.2, which would be a tangent line approximation. So I definitely want to sketch something right here, guys. I don't think we know this content well enough to be able just to theorize our way through it. But the one thing I notice is that they only gave me information about the concavity of the graph, not about the behavior. And while that might bother you, I want to remind you guys here that in any tough test, like an AP test, or an SAT or an ACT, if they don't give you information that you think you probably needed, that actually probably tells you you didn't need it. If that was necessary to know, we wouldn't be able to solve this problem. So I'm going to draw a curve that's concave down, and I'm going to say increasing. Not really sure that that's important or not, but I'm going to draw a curve that's increasing at a decreasing rate, kind of looking like this. Okay, and we're talking now about a secant line that passes through the points 3, f of 3. So I'm just going to eyeball here. I don't really care that much about the accuracy of my graph here, guys, in this regard, but there would be 3. And then over here, I'm going to put a spot right here, which is going to be 5. Okay, and my secant line, I'm going to go ahead and draw in green. That is the one and only line that passes through and connects these 2 points right there. Gotcha. I didn't draw that very well at all, but okay, I think we got it. So what we have in green there is that secant line function, which is s of x. And in blue, should have written this down right there, we have the curve itself, which is f of x. And then we've got a tangent line here too that I'm going to do in red. And that tangent line is tangent to this graph at x equals 4. Not surprisingly, 4 would be right smack dab in the middle right here between 3 and 5. Okay, so this is where I think we're at right here, guys. And if I'm drawing the tangent line approximation looking here, boy, it kind of looks to me like that tangent line would have roughly the same slope itself as the secant line itself. This very often happens, especially with quadratic functions, you guys, where when you take the midpoint here between your a value and your b value, your interval of secancy, that midpoint there gets you a parallel tangent line to the original secant. So I think that's what we have. Now, I'm not guaranteeing they're parallel, but okay. But the important thing to note here, guys, is that everything they're asking us to consider isn't what happens at x equals 4, but rather at x equals 4.2, which is a little bit to the right of that red point that we just came up with. So if I were to go up to 4.2, in fact, let me draw myself a dashed vertical line right here at 4.2, I think I can kind of tell what I need to tell right here. What they're asking us to compare in all 4 of these options are the y values here, everybody. And I'm sorry, I forgot to label my red tangent line there. That was t of x. And what it looks like here, guys, is that the highest of the 3 values right here at 4.2 would be right there on the red tangent line itself. It looks like t of 4.2 is going to be the greatest of all of those values. Followed then as I go down by, boy, this is going to get crowded right there. That value right there is going to be f of 4.2. And then on the bottom of this whole mess, the lowest one it looks like we're going to have is the secant value. So that would be s of 4.2. So it looks to me like they've got this in ascending order. S of 4.2 would need to come first, followed by f of 4.2, and lastly t of 4.2 would actually be the greatest. So I'm inclined to say right here that my answer for 88 is C. I am curious real quick if that would change if I drew a curve that was decreasing but concave downward. So maybe something that looked like this. And if I tried to do the same thing very, very quickly here, guys, without boring you too much. All right, if 3 got me right here and 5 got me over here. There's a point. There's a point. Okay, gotcha. 4 would be in the middle, and 4.2 would be just a little bit past that. So again, my secant line would be in green, so it would look something like that. Okay, the tangent line I will once again do in red at 4.2. Okay, I'm sorry. The tangent line is drawn at 4. There you go. So my tangent line would again look something like that. Okay, gotcha. And then at 4.2, yeah, guys, it looks like the exact same relationship between those three y values works out. It looks like S, the secant line at 4.2, is the lowest, followed by F of 4.2, and then lastly followed by T of 4.2. So it looks like in either of the two cases that I can think of here, C would have been the right answer, so that's what we've got for number 88.